exponential population since China, India, most of the European countries, Korea is as well on board, and many African countries, and the United States and Canada, and many Latin American countries. So it's really maybe 2/3 of the overall world population which are going to be potentially involved. And I think it's quite interesting project that we'll be launching early 2021. And finally, health and biomedicine. We live now in a quite complicated situation due to the pandemic. And health is something that, unfortunately, taking care of ourselves as a society is something quite essential in order to able to survive as a human species. And in this regard, from exponential point of view, I do consider that this is something quite important, not because we are doing, but joint forces around the world, all institutional educations that provide content in health and biomedicine is essential in order not only to produce as fast as we can the right vaccine, but in general to be able to cope with major disease all over the world. I think I'm running out of time, so I'm going to be a little faster, Professor Wang, if I may.
Yeah, that's okay. Go ahead.
Just speaking briefly about our International Academic Board, we are more than honored, and we're very humbled in this regard to have 3 Nobel laureate in economics, which is for us quite outstanding. And in addition, we have quite prestigious academic that belong to different parts of the world. More than 30 countries are represented, and of course, we cover fundamental, different types of topics from the academic point of view. And of course, they belong to quite prestigious universities. Very briefly, there are institutions, universities which are supporting us in all our activity. And on this final part, quite very fast, but just to highlight a few issues that we consider are important. In terms of digital identity, how important is to know that John Smith is John Smith. So there's a great deal of work in this regard, not only for financial institutions, not only for health institutions, but also for educational institutions. We need to be as much as possible able to identify that those that decide to be enrolled in our programs, and I'm speaking about Exponential, I'm speaking globally, are those John Smith. And when they receive their final certificate on the very final day, when they succeed in all the evaluation process, we have to understand and we have to be sure that the person which delivers the certificate is the right one. So in terms of proctoring, I think there's huge potential of doing innovation, and this is the beginning of a very large path that many companies have to follow. And of course, from Exponential, we're more than interested in not only applying advanced proctoring, but as technology evolves, trying to be, surfing the wave all the time to incorporate the latest technology in this regard. Now we are having a quite pleasant Zoom connection, but technology is evolving, and we want to include in Exponential Education a lot of, audiovisual resources, not only the professor being recorded, but included, and as years goes by, we'll be able, to accelerate this process by introducing augmented reality, virtual reality, many, 3D infographies that will allow, to have a better understanding for all type of candidates. And of course, artificial intelligence, it's quite important in order to try to identify hidden paths that sometimes is not easy to understand. But in terms of analyzing our data and sometimes the output that provide candidates, artificial intelligence will allow us to really be able to provide a much more professional and complicated services. And lastly, gaming and simulations are essential. I do know that your university is doing great things in this regard, and of course, we want to continue innovating in this process and continue, to evolve by incorporating all these resources to our process, and of course, within our exponential lab. So, going now to the very end of this presentation. Being completely native online, we do understand that we are able to move very fast, very flexible, with very highly applicable academic content, and with the process that will allow us to continue providing support to our oral students, and with a very problem-solving approach, which is the way how sometimes it's better in order to understand and solve problems, and even that flexibility allow us to have quite a customized educational itineraries, which allow candidates to identify and select which is the content of the courses they want to follow in order to achieve certain goals that they may have. I think maybe I'm running out of time, so once again, Professor Wang, on behalf of the entire Exponential Education crew, it has been an honor to me to do this institutional presentation about Exponential Education. And now I want to introduce Professor Alberto Corredera, Professor Jose Maria Moya, which are really, with your professors, really the key speakers of this event. Thank you very much.
Thank you, Sergio. Right. And maybe from now on, as we discuss, Professor Hyun-Young Yoon will be, will be talking about the data policy in Korea. And Professor Yoon is actually the professor in information technology, and currently teaching in our ITPP program, International Technology Professional Program. At the same time, her research dwells in traditional networking, especially in wireless networking and spectrum management. Now her actually study expands to AI and also data-related management and policy. And she will be talking about data transformation in public sector from Korea. Over to you, Professor Yoon.
Okay, thank you, Professor Huang. Good morning and good evening, everyone. My name is Hyun-Young Yoon from Seoul National University. It is an honor for me to participate in this session. And the theme of this session is how to make smart cities smarter. And I'd like to share some Korean experience about data utilization policy to promote data and digital economy in Korea. Because we can say in the first industrial revolution era, as my understanding, to be smarter means that to have data and to utilize data so that we can create the value and be smarter. So let me start my presentation. Okay. So as you know, the data, which is the core input of the fourth industrial revolution, is recognized as raw materials such as petroleum, and it becomes a source of competition that overwhelm existing production factors like labor and capital. So the success of the fourth industrial revolution depends on the formation of the high quality data market, acquisition of advanced artificial intelligence technology, and the systematic ecosystem of them. So in Korea, there has not been enough data value chain market formation, such as construction or distribution and utilization, and there are the AI technology gap between the countries like United States and China. So it was necessary to develop policies for fostering each value chain's strategies and accelerating convergence of them from the government side. And it started from the public data. So public data is the public information that lead to the communication and cooperation of all the materials and information produced by the public institutions and the public. So if each public institution share and list the public data, they can be opened to the public to the portal. The data can be reborn as high quality public data that can be analyzed and can create new value. So South Korea has been ranked as the top digital government among 33 countries in the league table released by the OECD this year. So some social problems can be readily solved using big data, such as using traffic data to help ease the flow of highway traffic, or using weather data to predict the next hurricane. So what if we want to use the data to help us solve critical social problems? The issues that are being tackled in the social sector are in many ways more complex than they are in the business or science, making the use of big data that much more difficult. In addition, the greater attention must be paid to the right of privacy and dignity of their constituent. So although this obstacles progress is being made, public sector agencies have made it clear that data are an important element of social innovation. Public institutions have made their data available to the public for mining and further use. So public big data portal like data.go.kr in Korea is, for instance. And the individuals are using the data to create innovation, mainly applications to address a particular social problems. Okay. So this is a kind of recent step of Korea government's public data innovation strategy. Since 2013, Korean government had tried to build a public data platform, and to do so, we established and enforced the public data law and constructed the first public data utilization startup competition. And between the 2014 to 2015, we set up open data portal and established the public data development strategy. And since 2016, we established several new projects to encourage public data utilization. So in general, public data innovation strategy focused on the establishment of an institutional foundation for provision and utilization of public data. Right. But even though we had tried many efforts on the public data innovation, there have been several limitations and issues. If you see from the slide, we had the asset of specific data, public data as an asset of a specific agency issues. It's not as a national asset, and some supply-centric public data, limit data delivery and identification, and also insufficient consideration of social value, and also lack of data-driven social innovation initiatives, and lack of data cooperation. So two, high barriers between the public and private, and also lack of awareness and expertise in this in the data-driven administrations. So although we had faced into those limitations, the data economy has been becoming more vibrant as data is regarded as like a crude oil in the era of fourth industrial revolution. So the government announced the transition to the digital economy in 2018 and made effort to innovate the whole cycle of data collection, storage, processing, analytics, and distribution and utilization. So in this regard, the Korean government developed the iKorea 4.0 policy brand to make the fourth industrial revolution more approachable and intuitive for the people. Here, the I stands for the intelligence, innovation, the inclusiveness and interaction, and 4 means fourth industrial revolution. And it covers major intelligent technology innovation project as your driver. And as you see, they are to support industrial innovation and the resolution of social problems. So the Ministry of Science and ICT has strived to play the role of an integrator for the past 2 years as the ministry in charge of the fourth industrial revolution and the science and the technology innovation to maximize the innovation capacity in the public and private sectors. So under the vision of realizing people-centered fourth industrial revolution, the government established the critical response infrastructure based on data, network, and artificial intelligence, so-called DNA. So innovated the national R&D framework and devised and has been implementing iKorea 4.0 strategy, aiming to improve the quality of life. So the strategic framework for data use for the action and improvement at the country level aims to strengthen the data availability and quality and used to drive innovation-led growth in Korea. So Public Data Innovation Policy Action Framework is published in 2018 when we just released iKorea 4.0, and it includes 4 strategies to accomplish creating a society that communicate transparently and create innovation with data. And the 4 strategies are like opening the public data and increase data access, realizing social value, and enabling database innovation growth. And I would like to share some key action plans of public data innovation policy in Korea. To open and utilize public data related to the social value, we plan to find public data on environment, safety, social welfare, and community, and also analyze and utilize public data to enhance the quality of public service and build up use cases and real services of big data standard analysis model, like a selection of area vulnerable to ambulance arrival and decision on pre-placement or something real services for the citizens and the people. And second, to resolve community problems and strengthening publicity through a participant of the people, we plan to activate participation from local residents to improve the quality of the public service. For instance, public participatory geographic information system, PPGIS. This is a tool that can be used to tell a story about what is happening in the people's communities, and also crowd mapping project. This is like local residents voluntarily point out the problems of the community and suggest a solution based on the geographic data, like a living lab. And third, to enable public-private cooperation based on the usage of public data, we operate open data forum between public-private participants and try to cooperate between central and local governments through data collaboration. This is some example in the smart city area, like data innovation city. So they try to publicizing the data of traffic and energy from the local government and to utilize the service, the cooperation between central and local government. And on the other hand, in order to become a country that utilize AI the best, Korean government announced its AI national strategies that include future national visions and strategies for the AI era last year, 2019. AI national strategies, which are made up of like 100 main projects from 9 main strategies in the 3 main fields. These are the South Korean government's plan and innovative economy and society plan to reach a new economy and to implement a better society through artificial intelligence. So Korean government is going to establish a leading AI ecosystem become a country that utilized artificial intelligence the best and implement people-centered AI to become an AI powerhouse. It is going to come up with nationwide AI strategies that consider characteristics of major bases by this year and completely open public data in 2021 next year, hopefully. And for this vision, not just only public data, but also R&D and private data also are utilized to build a national AI data infrastructure. So building massive data set that machine can learn and establishing national data management system is the goal of this data and AI economic action plan. So to do so, public data is converted into a machine readable format, and it is opened. So open in a real time to systematically accumulate sensor data for the Internet of Things device production, and also providing smart cities IoT data in connection with data platform. To achieve this goal, here are also some important and major action plans, and this is one of them. So advancing sharing government-wide platform aims to create an intelligent IT infrastructure that enables a smart government and encourage a balance between data usage and security of data by conducting joint research among multiple ministries through collaboration and resource sharing. So by applying AI solution technology, data analysis, and cloud-based infrastructure to e-government service, it aims to enhance the efficiency of government service and exclude duplicate investment by sharing data and information among the different ministries. Furthermore, the government will establish the data integration management system, such as Big Data Center, which interconnecting national data collection that can be used jointly by the public and administrative agencies and offer advanced AI-based analysis environment. This is one of the plans of public-oriented service for artificial intelligence and big data convergence. The Ministry of Interior and Safety and Ministry of Science and ICT, they promote the smart disaster safety management system to utilize big data, 5G, and augmented reality and virtual reality, and artificial intelligence, and amended autonomous vehicle for the disaster safety. And also, this is the case of weather data and predicting the agricultural productivity. So decision-making through forecasting model of crop yield considering various weather variables. Okay, so Korean government has tried to rebuild and amend the rigor system to promote intelligent information system. We have three major data privacy laws. Collectively we call the Data 3 Act, and which are the Personal Information Protection Act, so-called PIPA, the Act on the Promotion of Information and the Communication Network Utilization and Information Protection, so-called Network Act. And the third one is the Credit Information Use and Protection Act, so-called the Credit Information Act. And these Data 3 Act has been amended recently this year. The aim of this amendment are to minimize the burden of redundant regulatory activities and confusion among the regulated person stemming from the previously overlapping data privacy regulations and multiple supervisory bodies, and also to develop a data economy by introducing the concept of pseudonymized data and a legal basis upon which data may be utilized more flexibly, so to an extent reasonably reflect related to the original purpose of the collection. And the amendment of PPAR, the Personal Data Protection Act, would clarify the criteria for assessing anonymous information and develop the concept of pseudonymization and strengthen the personal information processor responsibilities. And also, the Data 3 Act would alleviate certain burden related to obtaining additional consent or expand the scope of the Personal Information Protection Commission and encourage development in like emerging technologies such as blockchain and artificial intelligence, autonomous vehicles, and fintech, among other sectors. So and also the Credit Act include provisions relating to pseudonymous and anonymous information and the strengthening of personal information protection in the financial sector. And Korean government analyzed how the Data 3 Act would benefit South Korea's effort toward obtaining like adequacy recognition from the European Commission, like GDPR. So that was the kind of as a major effort for the data utilization from the public from the government side in Korea. And finally, to summarize all the actions and the goals, in order to rebuild all the area of nation and society to digital and support all the easily and freely create, distribute, and utilize data capital to achieve innovation with growth and digital social innovation, Korean government is considering three main national agenda items for the digital transformation. First, a country where data is used in the safest way. And second, a country with the best digital government. And third, a country that builds digital capacity of all citizens. So just like e-government has played a role of promising water for the growth of IT industry within South Korea in early 2000 the period, South Korean government is hoping that digital government policy will have a same impact for it become a powerhouse in artificial intelligence industries. The Korean government is taking the lead and introduce advanced technologies, and it expects that it can be a positive example for the private companies and other major countries to carry out their own digital transformation. So for the sustainable development of the intelligent information society, people should have digital citizenship according to the social changes and strive to strengthen the capacity. And also considering recent emphasis on the strengthening the competitiveness through use of data, as well as the global growth trend of the data industry in particular, it should be discussed in the long-term perspectives, include policies to improve the legislative system based on the social consensus on use of data, build the legal system, and train and supply data professionals, enhance social awareness of use of data, and also establish data standards, improve the quality of public data, and induce the private sector to open low data in the market. So, right, that's the all thing I wanted to share today. So I finished my presentation, and the Professor Jose Moya, would you please take over next presentation?
Thank you very much. Let's see. One moment. Where it is. Can you see my screen?
Yes.
Okay. So, good evening, good morning. My name is Jose Moya, and I'm going to talk about opportunities for energy efficiency in smart cities. Specifically, I'm going to talk about something that is growing at a very high speed, which is the computing the computing resources that we need for that data orientation of our activity, of our economic activity and other personal activities that we are facing now. In fact, in data centers in 2011 consume more than 2% of the total worldwide energy consumption. And things are getting much worse with smart cities, with IoT, and also with the pandemic. Also, we have seen a huge increment of data center usage and demand. And there are estimates that predict an increase in data center energy consumption of up to 8% of global electricity consumption by 2050. And data centers also consume huge amounts of water for cooling purposes. And in fact, they consume more water than automotive industry, paper industry, or plastic industry. And as we have already seen, we are facing a digital transformation of every human activity. And that means everything is going to be oriented towards data. And is not only we do not only need the data to be available, we need computing resources to analyze that data fast enough and with the latency requirements of every service in the smart city, for example. And so smart cities and IoT are making things even much worse. And so it is supposed that by this year we have about 20 billion devices connected to the Internet of Things, and those devices are generating data. And we are not even started our real services for smart cities and for smart societies. Just to give some examples. Still, autonomous vehicles or even advanced driving assistance systems are not even started. Personalized medicine or I don't know, but for example, the demand of video conferencing and so on has grown like 3 orders of magnitude with the pandemic. So the demand for computing resources to analyze that data at a reasonable pace is huge. And with the current technology, the structure of our cloud services and the networks, the risk of collapsing the networks and to get results at a very high latency that is not good enough for the services is very high. So that's the reason why the current cloud-based computing paradigm is evolving towards an edge computing paradigm. And in the edge computing paradigm, the idea is that the cloud delegates computing tasks to computing resources that are very close to the data, to the origin of the data. And it's getting closer and closer. And And currently, hyperscalers, for example, are using colocation data centers that are close to their customers. And those colocation data centers are their edge data centers. It is not really very, it's not going to be like that in the future, but currently they're using those data centers as the edge computing resources. And that means that even if the hyperscaler data centers were very, very efficient, in fact, for Google, Facebook, Microsoft, or Amazon, the data centers consume like 10% of energy in cooling. Now they are using colocation facilities close to the origin of the data, and in those facilities with current cooling technologies, it's not so easy to be very efficient. And the computing resources that are at the edge are expected to grow very fast. And so the efficiency of the data centers is expected to be worse and worse every day. So we need to do something with that. And just imagine, for example, that if we have, in most places in Spain, we get temperatures around 40 degrees centigrade during the summer. And during the summer, of course, air-cooled techniques for data centers is not going to be at 10% of energy consumption. In fact, the average in the world is now about 50% of energy consumption in cooling. And as we move towards the edge, that is expected to go worse, to spend too much energy in cooling, and so to be very inefficient. So that's the reason we propose this kind of, sorry, I'm going to hide this. This is our proposal for edge data centers. That you can see on the right of the image. It's built on a standard 10-feet ship container and uses two-phase immersion cooling techniques to save to even eliminate every energy consumption for cooling. This design allows the fast development of scalable edge data centers that in smart cities that can be scaled up or scaled down as needed for the services. And it also allows to save about 50% of energy consumption because there is no need for energy consumption for cooling. And it's mostly a passive cooling system, and it works very efficiently in every possible climate. It allows to increase the power density orders of magnitude. In fact, theoretically, the dielectric fluid we are using allows to have power densities as high as 1 megawatt per cubic meter, which is much more than the maximum power density we can reach with current hardware. And it also reduces IT costs because there is no need for cooling devices in the IT systems, no need for fans or heaters or so on. And but it is important to note that if we really want to take advantage of this technology and to make if we want to make it really competitive, it has to be optimized case by case, because there is lots of opportunities to optimize costs and efficiency and performance just by taking into account the application. So we are now working on a prototype for low-cost data analysis based on neural networks, and what we do is we have a immersion tank where we put computing blocks that includes all the CPUs inside, and as normally at ambient temperature the fluid is liquid, but as we run the analysis algorithms in the CPUs or GPUs, it gets hotter and hotter, and if it reaches 60 degrees centigrade, then the fluid evaporates. And that evaporation means a phase change that absorbs a lot of heat, and also the bubbles go up naturally. So there is no need to remove that heat. It's automatically removed from that point. And that vapor condenses passively in coils refrigerated with cool water. That's an amazing technology that makes possible a huge density inside. But of course, it's not as easy as it appears to be, because there are lots of optimization points that we had to take into account. So we have been developing dense computing resources using standard GPUs. In fact, we are removing the cooling system, the heaters, the fans, and the heat pipes and everything, so that we can put two blocks like this interleaved, so that we can have like 54 GPUs in 1 cubic meter. So it's a nice, a dense system with low-cost devices that, of course, is not possible to cool with the air cooling systems, and it makes it possible lots of applications that are very interesting. So we have run many experiments to analyze the behavior of the GPU in this system. That is the way it works, and it is condensing in these small condensers. And the problem with this system is that this graph represents the heat flux versus the temperature of the surface, the surface temperature. So as the temperature increases, bubbles are created, and if there are many bubbles, then the capacity of the fluid to remove heat is very high, and it grows exponentially as bubbles increase. But then there is a point that there are mostly vapor. There are many bubbles, and so it's not so easy to make new bubbles. It's not, there is no liquid to evaporate. So at that point, which is called the critical heat flux point, at that point, the heat removal capacity of the liquid falls sharply, and so it is possible, if we reach this point, that everything breaks because of a huge increment of the temperature. So we had to be very sure that we do not reach this point. and also take into account that the heat removal capacity of the fluid is very low at low temperatures. So during the starting and at close to the critical heat flux, we have to be very careful, and for that we need predictive models and so on. But even if there are problems to optimize and to automatically operate with these devices, the transformation power that this technology has is really incredible. For example, think about digital driving assistance systems. Even before there is autonomous vehicles, we can save lots of lives just by avoiding accidents with video processing. And for that video processing, we'll need lots of computing resources very close to the cars because the latency is very important. So lots of these small data centers distributed around the most critical the most critical roads will allow to change the way the accidents are avoided and probably have a huge impact. There is another application that is very, very important, that is personalized medicine. Now there are many medicines that cost lots of money for public health systems, and by analyzing data, continuous data from complete populations, we can predict the symptomatic crisis and any other event that requires specialized attention. So we can save lots of money. For example, we are working on a project for migraine prediction. Migraine have a huge cost for many companies in the world, and we have learned that we can develop quite accurate predictive models for migraine crisis, but those predictive models are specific for every patient. So we need a lot of computing power to make and to maintain predictive models for every person that has migraine. But if we can predict those crises, then the medicine can be taken at the right moment, and we can avoid the effects of the attack, of the crisis. And then there is another application that has a potential of transforming everything in the world. That is the development of the computing resources of underdeveloped countries. Data centers are very capex intensive. You need a huge investment to have a data center working. But this kind of data centers is really very cheap, and in fact the highest cost is to maintain the system running and in an optimal way, and that reduces the barrier that many countries have to develop a full infrastructure to really also to transform their lives and their economic activities towards data analytics. And there is also something that is very interesting, that if we have lots of small data centers distributed around many cities, then we can federate those data centers to work as a whole. And the advantage is that those small data centers may have some renewable energy generation capabilities and also some energy storage capabilities, and we can take into account those capabilities to make sure that everything that we had to run is running in the place that is that guarantees my quality of service, and at the same time saves most energy and is more efficient for everybody. Okay, so a federation of these kind of data centers can be even competitive with huge data centers from hyperscalers. And so there are many different aspects where we are trying to do some contributions around this idea of this model of computing in the future smart cities and the federation of smart cities to make available this social transformation. And that's the introduction of the main project we're working related with energy consumption in these kind of environments, and the possibilities it's open, and of course, and open for any question during the round table we had later. So now I don't remember exactly, but I think it's Alberto.
Yeah, thank you, Professor Jose Moya. And so I think we have also the next speaker from SNU side, and Professor Song Young-gun from Graduate School of Environmental Science. And Professor Song is also the faculty member of Transdisciplinary Education of Smart City Global Convergence. And Professor Song Young-gun will be talking about the urban management, from the aspects of the data management. So Professor Song, it's over to you.
Okay, thank you for having me today, and thank you for inviting me. Good evening, all. I'm opening the files. Let's see. 보이시나요? Did you
Yeah,
see?
we can see.
Yeah.
Okay.
Okay.
Okay. That's wait a minute. Okay. Today, I'd like to talk about with the title of urban ecosystem management in the smart city. So I am the professor in a graduate school of environmental studies, and I am leading my lab named Landscape and Ecological Planning. So today's my topic is not actually smart city, not just focus on smart city itself, but I'd like to include some issues from the ecological city and green cities issues. So first of all, I'd like to mention about the smart green city. Actually, this smart green city is invested now. The government would like to invest a lot of money in the name of a smart green city, and that was part of the Green New Deal, and which was for overcoming the COVID-19 crisis. So it is huge money. It's more than $70 billion since from now to 2025. And this kind of a smart green city is the trend is the different version of from the Ministry of Environment. So maybe it includes smart technologies, for example, to IoT, big data, and networks, something like that. But that kind of technologies is combined with green city technologies. So that is consists of 10 different sectors. For example, climate resilience and water cycle system, and some water security, water safety, and future mobility, and waste or resource cycles, ecological restoration, recreation, and clean atmosphere, and environmental education, and living environment. So these fields are basically dealt with the Ministry of Environment of Korea, but they would like to combine these kind of sectors with smart technologies in the name of a smart green city. And scientists emphasize the importance of the ecosystem, even in the urban areas. So in the science, they compare about the crisis of environment to some crisis in different sectors, and this biological integrity and some biological cycles are very high, under very high risk than any other parts of our environmental crisis. So that is why we should be careful for solving some environmental problems, especially focus on some ecosystem problems in the urban areas. So first of all, why smart in green and green in smart? First of all, the urban I'd like to mention about the keywords of the urban ecosystem. Because the urban ecosystem is a very unique type of ecosystem that was very vulnerable because it always facing with some development pressures and some destruction pressures from the human side. But it is very precious. It is very important because it is very closely located, and it always provide very everyday experience for the natural environment for the citizens. And the green infrastructure topic is very important because it shows a multifunctionality at one place. For example, we can imagine about some facilities on some countermeasures for the heat stress, or for the intensive rainfalls, or for about the carbon things and air qualities and urban biodiversities, things like that. There is many ecological issues, but green infrastructure can solve that kind of many problems, ecological problems at one place. We can call it is multifunctionality. So that is why this kind of green infrastructures are important, especially in the urban areas, because we cannot always make the large green areas, especially in the urban areas. So we should think about the multifunctionality at the one places. And third thing is urban ecosystem service, because ecosystem service is very strong and powerful tools to include the citizens. So So when you think about the literacy of the environmental crisis, especially for the citizens, we should think about the urban ecosystem service, and that kind of topics are contributes to having the sustainable city and SDGs. And how can we achieve that kind of smart green cities? There are many ways, but I bring some key themes, key results. For example, some planning aspects we should think about the ecological axis and network. We cannot always opposite, or we cannot always disagree with many city development and city expansion. So we should think about some harmonized solution between the development and conservation. So when we think about that, we first of all we should think of this kind of backbone to provide urban ecosystem services efficiently. So please don't develop this kind of backbone. But instead of that, we should allow the other areas more compactly, right? And that kind of ecological access and network planning is already established in Korea, in the national scale, in regional scale, in local scale, in the city scale already. And that kind of ecological access network was protected by we'd like to protect that kind of things by the law. And secondly, to achieve this kind of ecological access and network, especially in the urban scales, we are all of the cities, all of the local government of Korea must make this kind of urban ecological status map with very high resolution, 1 to 55,000, and that kind of maps are using for decision making. For example, for the Seoul city, built up grade, first grade, very high natural values, we cannot develop that kind of areas. So this kind of planning aspect is very important, and technological aspect, we and Minister of Environment and Environmental thing, there are already environmental technologies already. So something is related to green mobility and water and waste and green areas. And this kind of green environmental technology should incorporate and should mix with the smart innovation technologies. So this kind of mix of technologies is promote to the smart green city. And some cascade model, which was from the structure, changing of structure and increasing and is upgrading the structure and process and upgrading the urban ecosystem functions. And by doing that, we can expect about the upgrade of the urban ecosystem services. So to do this kind of cascade, to achieve this kind of cascade model, so there are several smart technologies. Actually, these figures are made in the movies, but today is my presentation through the Zoom, so I just cut the several cuts. And remote sensing technologies and three-dimensional high spatial and temporal resolution monitoring technology for about green infrastructures in the urban area. We are using this kind of technologies and monitoring technologies to understanding the ecological structure. And based on that kind of ecological understanding of ecological structure, we'd like to develop assessment technology of the ecological functions. For some part is related on the heat stress, damage of the intensive rainfall, carbon sequestration, air quality, urban biodiversity, and something like that. So firstly, we'd like to assess the vulnerability of at the local scale, urban scale, and regional scale. So based on that kind of assessment, finally we should find a way to restore that kind of ecosystem structure and functions. It is very important because all of the smart technology would like to focus. That kind of technologies are mainly focused on some monitoring and assessment itself, but we should develop that kind of technology in terms of restoration. Yes, that is very important. And second, the evidence-based adaptive management. When it comes to the ecosystem, it is very complex, and we cannot perfectly estimate of the planning effect. So, by feedback from the application, we should fix our management ways. And lastly, the governance is very important. So in our lab, we'd like to do this kind of technology development with the citizen, as you can see. Yes. So that's all. Thank you. That is all my presentation.
Okay, thank you, Professor Song. And so we're back with some Q&A and a discussion on some kind of, what kind of challenges and also the advances, we probably need to make in smart city development. So now we will, give our mic to Alberto Corredella, Professor. Over to you, Alberto.
Thank you.
Professor Song, would you please close your...
Okay.
Okay, thank you.
Can you see my screen? Yes. Okay.
Yeah.
Well, hello to everyone. After covering the introduction and consideration of our smart cities, my name is Alberto Corredera from Exponential University. I want to thank the host for inviting me. I'm so glad to be in this Congress. And I'm going to talk about the concerns about managing complex infrastructure like smart cities. That may appear as a result of introduction of artificial intelligence in the city environment. According to some sources, such as the tech journal Nature, the most pessimistic estimates of consumption by information technologies for the year 2030 are that we could exceed half of the global consumption and almost a quarter of greenhouse gas emissions. The most specific data on the cost of service interruptions today is that the service outages in data centers cost on average $1.7 million per year. Among with the main causes of discontinuities, 22% were due to human errors. Imagine what we could be the cost for an entire city. The market for cloud providers like the hyperscalers is currently exceeding the $100 billion a year in business figures. The cost of each hour of systems failure reaches even greater values. All these facts without mentioning the possible reputation that could manage those economic exposed is difficult to calculate at this point. According to the annual survey conducted by the Uptime Institute to companies in the technology sector in the last year, 60% of the downtime of the data centers would have been avoided with a proper management and configuration system. The speed of machines is replacing that of humans. We have billions of devices that are connected to the internet. The population expects more and more multidimensional experience, such as the increased capabilities that mobile devices provide us with an increasingly shorter response time. As infrastructures are becoming more complex, our work can have very diverse implications. We use personal productivity tools, individual and collective system monitoring tools that we can use for collecting that information in a way that is easier for us to manage. Sometimes several people from the same team act on the same system, being able to have different perceptions of the possible severity of an alert on the context that we are working, okay? Talking about emotions. In emotions, we call primary emotions to those that produce a physiological reaction in our body. They are the body's first response, and they are generally very easy to identify because they are so strong. The most common are fear, happiness, sadness, and anger. There does not have to have a great stimulus to provoke these primary emotions. On the other hand, the secondary or tertiary emotions are more complex, so they require a certain degree of cognitive development in the individual to elaborate. They are also known as social emotions, since they arise in context of interpersonal relationships and the combination of several primary emotions. Emotions can be scientifically expressed in numerical formats so that they can be compared one to another. Using these dimensions, on the one hand, we have the valence or the polarity, and on the other hand, we have activation or arousal. The term valence is used to characterize and classify specific emotions. For example, emotion popularity known as negative, such anger or fear, have negative valence. Joy has positive valence. The arousal or level of cortical activation is a term from medical neurology, physiology, and psychology that designates a general physiological activation of the organism, which varies on a continuum that goes from deep sleep to intense arousal, like when we cry. Different emotions can have the same level of arousal, such as euphoria or anger. Faced with the perception of an emotional stimulus in the brain, there are a series of structures that can carry out the processing of emotion depending on the emotional balance of the stimulus. This circuit connects with the hypothalamus, which triggers physiological changes such as accelerated heartbeat or increased sweating. To represent the measurement of a model, an optimal system, we have built the following block diagram to represent these models. A model for monitoring. The objective of this subsystem is to capture the emotional information and produce the main indicators. The optimization model deals with the information processing. It is in charge of discovering trends and defining the variables to control performance. The policy and the regulation model includes implementation of data protection or occupational risk prevention policies, like GDPR. Action model. This action model, you may be able to recommend adjustment to the temperature, humidity, or environmental noise, or any other control variable or supervision mechanism based on previously defined policies. Finally, we need to represent the general system and to close the loop. During our research, we included a proposal of an information extraction point. The represented invention relates to a method and a system for managing the operating personnel of a complex infrastructure such as smart city. It comprises first sensoring system for measuring a set of physical variables of an infrastructure operator, an analysis model for associating the measured variables with arousal and balance values, and determining based on certain values a predominant emotion of the operator. The second sensor means to identify a state of operation in the infrastructure. A process model for determining a corrective action based on the current operating state and the predominant emotion, and a display model configured to provide corrective action to the operator as we related in the previous representation. Okay. We perceive emotions through language, spoken or written, or from facial expressions. From Darwin to the present, the facial expression of emotion has been fascinating, a field of study that authors like Tompkins and Ekman has assumed the innate character of facial actions that are a reflection of emotion. One of the first experiments was carried by Dr. Duchenne, who applied small electric shocks to the facial muscles to generate certain expressions. This was a starting point in the systematic study of facial expressions, giving functional value to the different facial muscles as units of action that could be used to classify the different emotions. The large amount of geometric information available in an image makes it possible to estimate the position of the face in the subsequent normalization. But differences between individuals, change in facial expression, occlusion or areas with non-acquired data contribute to increase the complexity of this task. The facilities on the smart cities are powered by data centers, and they tend to be increasingly complex, as we have commented. Among the multiple variables to be monitored within the data center, we can find temperature, humidity, memory use, CPU use, electrical power consumed, and countless parameters that are currently being monitored. Our job is to select the most representative ones in order to have a complete vision of what happens in that workspace. In one of the projects we implemented with one big European telco in our research lab, we carried out a series of tests using an audio and video dataset called Recola from the University from Freiburg in Europe that we use as training. Then used tests in experimental environments at the telco and the university to determine an emotion that precisely with an emotion precisely. The excitement, the arousal, and the balance, and the combination of a large number of variables. The audio variables will have a greater influence in determining the level of arousal of a person. Quite intuitive if we take into account our day by day. Okay. We recognize more easily a person arousal, that is the energy invested during the emotion, by the way they speak, whether they shout or not, or they speak quickly or slowly, more seriously or subtly, than by recognition facial variables. However, in terms of balance, which is the main dimension with the emotional experience that corresponds to motivational component of the emotion, that's pleasure or displeasure, that is in an emotion in positive or negative. This is highly identifiable with a facial image on the subject. Additionally, we took into account that verbal communication in a smart city operations environment does not produce much information as video monitoring. During this mentioned research project, we ran an experiment related to task execution. We took 50 samples of 12 employees, and we took these samples of common operation activities and tracked the time to complete those procedures. In those 50 samples, we recorded the initial emotion detected in the first minute of the task. The routine tasks mentioned are performed, and the time it took to complete the task was recorded as well. In this figure, we measure productivity as the deviation from the base time. The reduction in time being negative and positive, the increase in the time during the execution times. All 12 subjects are people with data center experience and have similar backgrounds. We ran those 50 different tests on the sample, detecting the dominant emotion, arousal, and the subject's balance. We use the employee information structure model for a test, and we mentioned that we mentioned in the most introductory section in the previous slides. The figure distribution of emotion summarizes the distribution of emotions for the 50 cases analyzed. This is important to note that there were no system failures when executing this task during the test. If we evaluate the impact of emotion on the duration of the task, as shown in the figure, we can see how emotion with a negative balance as anger and sadness have a negative impact on productivity. That is, they delay the execution of the task by an average of 4 to 2 minutes, respectively. Happiness, on the contrary, tends to increase productivity, saving time during task execution by an average of 2.5 minutes. Neutral and surprise emotion do not influence average task duration, although neutral cases tend to reduce time spent on task. By focusing our attention on the balance and arousal drawn from the subject's emotions, we found these results. As shown in the figures, balance impact and arousal impact, the balance of an emotion has a significant impact on productivity. The higher the balance, the higher the productivity of the subject. Arousal does not have a clear trend, but it seems to have two different trends. Up to the inflection point of an activation of 0.41, and productivity increases proportionally with an activation value from excitation of 0.4 onwards. Productivity decreases as excitation increases, so high excitation values appear to be having a negative impact on productivity, what we could associate with euphoria or anger. After those experiments, we decided to build a management console in order to control and visualize both the system and the emotional variables. Here you can see the operator tracking system. In this screen, we are able to see the data center view with the monitoring of the system showing the load of a specific infrastructure. And lastly, in this screen, we can take a look to the human resources view, comparing the emotional and biometric variables with the general health of the system. This was my last slide of this presentation. I hope this presentation was interesting for the audience, and let me hand it over to Professor John Song. Thanks a lot for your attention.
Thank you, Alberto. Over to you, Professor John Song. And Professor Johnson is actually Deputy Director of Global R&D Center of Seoul National University. Johnson will talk about the SMART, actually, and so we'll see what philosophical education he will talk about. Thank you, John.
Thank you, Professor Huang. Thank you, Alberto. I'm really happy to meet the professors of Exponential Education and all the friends through the wonderful link of YouTube. If I may introduce myself briefly, ethnically, I'm a Korean. Nationally, I'm a Canadian. And spiritually, I belong to the tribe of Little Prince. So through this GSDV conference, I would like to find my tribeman among the audience, as well as our friends at the Exponential Education. Today, I would like to talk about something that's a little bit different from the technology side approach. So our theme is how can you make smart city smarter? And I think we have to think in a smart way to build up smart cities smart. Actually, the etymology of smart is, it means there is a keen stinging. It's a breaking up the dullness of our life or our thinking. So I would like to suggest to fly into our brains tonight. I'm a strong believer that big thinking is what we need. So the size of thinking determines the size of change we can make. Actually, this is my motto of thinking and working. And I would like to ask, are we smart in doing what we are doing? Sometimes we need to think at the height and the tall tower to see what we are doing. Sometimes I observe a huge collective stupidity in building smart cities. It's like building an ostrich, which is the fastest bird on the land. It's not the fastest bird in the sky. So, ostrich cannot run faster than cheetah. The cheetah will catch up the ostriches on the land, and they will eat all the ostriches. That's a tragedy. I don't want to criticize all the precious efforts being taken by so many countries, municipalities, technology leaders, and engineers about smart city development and build. But I would like to suggest that we take short hold to think about what we are doing actually. Mr. Bruce Ma, through his book, A New Digital Deal, he suggested that the one that would probably prove most successful in this stage is the so-called Smart Cities Worst Practices Summit. So he argues that beyond the pond, that the front and the PowerPoint will provide city leaders the best of insights, but the back end to those same presentations, the pitfalls, the lessons learned, the failures, actually can provide proof that's more helpful. Actually, Mr. Bruce Ma goes on to suggest that there are 12 reasons that smart city initiatives can fail. The first one is when the smart city is struggling with the game of the name. So it's struggling to define the name of smartness. So actually, if we look at all the smart city related initiatives, we can't see what actually smart means in their names. What is it? And we are trying to define the smart in all smart city initiatives. When we are trapped in the battle of defining or the real meaning of smart, then you can fall into the continuous loop of just philosophical debate. Second one is technology myopia and too much dependency on solutions, and lack of clear objectives. And when smart city development is just a matter of public sector procurement propaganda, or organizations are stuck in silos, or no plan to replicate or scale up the initiatives. And digital divides and lack of community communications and legacy IT suboptimal networks, and one-sided approach like top-down versus bottom-up, and closed architectures. And finally, when we say that cities must be tall and large enough to enter the Smart Cities Club. One of those examples of the failed smart city in the world is the city of Ordos in the Kangbashi area in Inner Mongolia, China. Actually, they spent US $200 billion to build the city. The global spending on smart city initiatives will total 124 billion in 2020, which is a 18.9% increase from 2019. It's reported by Smart Cities World. So all those cities spent $200 billion to build the city from early 2000. And we now have this beautiful city with no person walking on the street. Amazing. The city was planned to be a city for 1 million people, but now we have 100,000 people living in the city. You see these beautiful villas. It's called Herzog and Muron and Weiss, all those 100 villas. No one lives there. And Sharon Betan, who is a columnist for Places and a professor of anthropology at the New School in New York City, said, a city is not a computer. It's not a network of ubiquitous sensors connected to AI algorithms on the backstage. Then what? What's the smart city? What's the city itself? This is the question we have to answer very smartly. Another example is the Santander city in Spain. Santander city in Spain is a city in northern Spain. It's a very beautiful, famous tourist city. And in 2009, it installed 12,000 sensors around the city. While in other major cities in Europe, like Belgrade, Lübeck, Guildford, has a total of 20,000. But Santander is not done yet. It's just half of the devices they are going to install. So smart cities are nothing if they simply decide to install sensors, which furthermore, when they are not mature enough for the mass market, or just sensors or technologies are just a pilot. But do you know what's the population of this Santander city? It's 170,000. So you have got 20,000 sensors or to be 40,000 sensors for 170,000 people. So it's amazing, eh? You are surrounded by all sensors. When you're biking, when you're eating, when you're drinking, when you're sleeping, every time, whenever you are monitored by sensors. So what? Being smart is actually what? What is it? In building smart cities, what's the most important thing? Like, is building a park? Is to make people happy? To provide better education? Or is it better logistics, transportations? Or is it for more businesses and marketplaces? Better farming, agriculture, or better energy, or health, security, and more advanced industrial systems, or autonomous vehicles? What are they? I would like to find out some solutions from very humble examples. That being smart is being contextually sensitive. The boys here are standing on what they call sand dam. A sand dam is a reinforced stone masonry wall built across a seasonal sandy river. They have almost no maintenance costs and can last for upwards of 60 years or up to 100 years. Water behind the sand dam raises the water table in the surrounding area, which improves the soil, creating better conditions for crops and grazing. More trees can be planted, which ensures that more water infiltrates the ground and less soil is washed away, creating a virtuous cycle of soil and water conservation. And as the water is stored safely within the sand, it is protected from evaporation, contamination, and disease transmitters such as mosquitoes and freshwater snails. So they built concrete wall on the river basin, and as rain falls down, the sands and the water are gathered behind the wall, and then the sands settled down and the water goes into the sand. And they use the water contained in the sand for agricultural use or for their daily life. This is a kind of very popular practices in Kenya and other countries, and there are sand dams that serve for over 1 million people. How much will that dam cost? 100,000, 50,000, depending on the size and the economical situation of each country. And another example is wolves. So I think being smart is enabling the flow of lives. Until early 1990s, ecosystems at Yellowstone Park in the United States deteriorated significantly and tremendously. So the rivers got dried, no birds chirping, no butterflies, and insects disappeared. And the grass base is it's gone. So the ecologist, Mr. Mike Phillips, thought about a solution. What can he do? And he came up with an idea of bringing wolves, proudly bringing the wolves from Canada. So they brought 15 wolves first time, and then they increased the number of the wolves they brought from Canada. And then finally, reliable data make clear that wolves have helped to reduce elk numbers and have changed elk foraging behavior, allowing for vegetation to recover from chronic overbrowsing. We have to think wisely. And one of those wisdom we can find is the thought from Oriental culture. We name in China, Korea, and Japan. Now China and Japan have some different names for the weekdays. We shared weekday names in Chinese character. The Monday is Il. It means sun. So sun is the primary energy. The Monday is moon. It's a secondary energy or renewable energy. The Tuesday is Hua, it's a fire. So it's energy efficiency, heating, cooling, cooking. Su is Wednesday, water. Mok is Thursday, trees and forest. Friday is Kum, which means metal. I think it means technology and transportation. And To is for Saturday, which means soil and land. So the whole days of week are the lives of all the fundamental elements of the universe or our environment. And air is surrounding all these components of our environment. And then we build up infrastructure based on these fundamental elements, and we build up economies, we build urban cities, we build up our health over there. So what I would like to suggest is that we have to think in a holistic way when we think about building smart cities. So smart city is the city where we have urban smart, industrial smart, environmental smart, energy smart, human smart, financial smart, and cultural smart, and as well as mobility smart are all included and all considered in an integrative way to provide personal value realization, culturality, health, efficiency of the city or the life, social security, safety, knowledge and learning environment, economic development, prosperity. So in realizing this smartness in every aspect, we have policy and regulations we could play with, urban systems, urban service and management systems, and we have citizens and environment and infrastructure. In transforming the legacy cities to new smart cities, I think we have to think about two areas. Always, transformation has two aspects, metanoia and metamorphosis. Metanoia is metaphysics. Metamorphosis is physics. So it means when we transform ourselves or the cities, we have to think about how we think, how we ideate, how we plan, how we talk, how we share our thinking. That's metanoia. We have to change them. We have to transform them to the new ones while we transform our physics, like infrastructures and technologies and parks and water systems and so forth. So we'd like to, I think we have to find out a way how we can develop a framework of holistic transformation. So now we are talking about New Deals everywhere, like in Korea, in Europe. So New Deals include two major axes, the digital transformation and green transformation. But at the same time, we have to think about economic transformation, which means that we have to pursue more inclusive economic systems. And at the bottom, we have to think about social transformation. What digital transformation and green transformation will do to the philosophies and thoughts and cultures and behaviors of citizens. So next slides are a little bit too much complex, but it means that anyway, there are lots of areas of transformation, lots of technologies, lots of frameworks we can think about in transforming the legacy cities to smart cities. But altogether, we need to have a holistic approach to integrate all the dimensions of the transformational frameworks. Finally, we would like to have inspirational values for humanity, holistic solution for transforming the whole city, agile integration, and implementable actions. And I think we can think about in the way, this is a scheme that I thought about in thinking, how can we take holistic action? So first, when we take an action, it should make a sense. And this sense is about sensing what we need, sensing what's happening. And then it means it has got the rationale. The rationale that we have a proof for the reasons for action. The next one is structure. It's architecture, framework, and organizations. And stream, which is very important. It's a flow of thought, flow of plans, flow of ideas, flow of finance. We should have a stream. Without the stream, the structure will just be there like dead snails. And the whole effort should be aiming for scalability or resonance between entities and between developers of smart city, and then speed. Yes, by 2030, we have to do something to prevent a climate crisis and other to achieve the goals for sustainable development goals. Finally, I would like to say, talk about President Abraham Lincoln. I learned about his speech at Gettysburg when I was very young, like 7 or 8 years old. He said, "The government of the people, by the people, for the people, shall not perish from the earth." So I think smart city is the same. Smart cities of the people, by the people, for the people, shall not perish from the earth. So I think we should try to make a flow of action. So we have to create actionability led by anchoring catalytic action first and with higher risk appetite. So this action can be replaced with the word investment as well. So flow of investment. Actionability led by anchoring catalytic investment with higher risk appetite. I like dandelion because I like it because, first of all, it's humble. It grows everywhere. And it grows very low on the street. Sometimes we don't notice them. But it's everywhere. And the dandelion seeds fly with the furs when a breeze blows. It goes everywhere. And when it lands, where it lands, it starts to grow. And then it produces lots of other seeds. Like for one stem, we get like around 250 seeds. And 250 seeds fly away when a breeze blows again. It's like bringing actions through the network of seeds. So I would like to see the world collaborating together, working together, thinking together to create resonance like dandelions. Thank you.
Thank you, John.
Professor Wang?
So very inspiring talk. So Leslie and Alberto again. Also, Alberto will talk about some risk and also some limitation of the technology, especially AI use of smart city management.
Thank you again. I assume that everybody is able to see my presentation. After covering the different elements and considerations about smart city, well, I have to say I really enjoyed John's own presentation, and I would like to think that there's a link or a connection between his presentation and mine. Okay, so it would be saving the distance between talking about AI, but I completely share his point. So I'm going to talk about the concerns that may appear as a result of introducing AI in the city environment. The risk and limitation of artificial intelligence in smart cities starts with the need we have to promote it in the cities that provide core infrastructure and give a decent quality of life to its citizens, a clean and sustainable environment and application of a smart solution. Integrating the various embedded systems in our environment as Internet of Things for a smart city. The IoT at the same time will generate a tremendous amount of data that can be leveraged for safety, efficiency, commercial application, and services for city residents. The management of this voluminous data through its life cycle is fundamental to the realization of smart cities. However, the use of these services may create a new atmosphere that may include fear, uncertainty, and doubt to the citizens. As per international and organization reports, more than 50% of the population is globally living in urban areas, and by 2050, more than 2/3 of the population will live in cities, providing big investment opportunities to the technological development companies. As per the IDC report, by 2021, the next year, the spending on smart cities is likely to reach more than $130 billion to make the urban areas and cities more level with advanced infrastructural facilities and society management systems. AI in smart cities is going to play a big role in making urbanization smart. Some of the services the smart cities are demanding are security and surveillance, public detection and movement, vehicle parking management, traffic management, waste and disposal management, drone-based aerial view monitoring, everything with the smart before it. However, getting this kind of services may raise concerns in the population in many ways. Talking about security and surveillance, we may need to rely on image recognition. Amazon's face surveillance technology is the target of growing opposition in the US. From 2018, there are 28 more causes of concern in a test conducted by the ACLU, the American Civil Liberties Union, using the facial recognition tool called Recognition from Amazon Web Services. The software incorrectly matched 28 members of the Congress, identifying them as other people who have been arrested for a crime. The members of the Congress who were falsely matched with the Maxshot database used in the test include Republicans and Democrats, men and women, and legislators of all ages from all across the US. The false matches were disproportionately of people of color, including the 6 members of the Congressional Black Caucus, among them the civil rights legend John Lewis, who passed away this same year. These results demonstrate why Congress should join the ACLU in calling for a moratorium in law enforcement use of face surveillance. Law enforcement agencies and more companies use it to identify suspects and victims by matching photos and video with databases like driver license records, but civil liberty groups say facial recognition contributes to privacy erosion and reinforces bias against Black people in the US, and it's prone to measure that there are facial recognition bans starting across the world. For instance, by the beginning of 2020, the European Commission has revealed it's considering a ban of the use of the facial recognition in public areas for up to 5 years. Regulators want time to work out how to prevent the technology being abused. The technology allows faces captured on CCTV to be checked in real time against watch lists often compiled by police. Exception to the ban could be made for security projects as well as research and development, of course. As Albert Einstein said, we have been endowed with just enough intelligence to be able to see clearly just how utterly inadequate that intelligence is when confronted with that exists. It is humility. If this humility could be imparted to everybody, the world of human endeavors would become more appealing. But Einstein also said that fear or stupidity has always been the basis of most human actions, as just Johnson said. As the famous film from the year 2000, Matrix, warned us to the risk of science evolution, the fight for the control of energy in a world with limited resources derives in the machine supremacy and the use of human life as a source of energy for feeding the machine necessities. This fantasy plays with our fears and with the idea of fighting against an evil intelligence. Another example of an evil synthetic intelligence is Skynet in Terminator Saga. Starting in 1984, the AI is commanding an army against human beings with the use of humanoids. But the real message behind the Terminator movie is that the future isn't written, and we decide our fate. In the film Her, in a near future, Theodore, the main character, is lonely, introverted, depressed man who works for a business that has professional writers that compose letters for people who are unable to write letters for a personal nature themselves. Theodore purchases an operating system upgrade that includes a virtual assistant with artificial intelligence, designed to adapt and evolve. He decides that he wants the AI to have a female voice, and she names herself Samantha. Theodore is fascinated by her ability to learn and grow psychologically. They bond over their discussion about love and life, as far as not wanting to date anyone because his life was covered. Without revealing the outcome, the same capacity to learn and to grow psychologically may produce a de-alignment in the future due to the evolution itself. But after all, Theodore found himself more human after the experience. Everyday corporations are connecting the dots about personal behavior, silently, scrutinizing clues left behind by our work habits and the internet use. The data compiled and the portrait created are incredibly detailed to the point of being invasive. But who connects the dots about what firms are doing with this information? The black box society argues that we all need to be able to do so and to set limits on how big data affect our lives. Hidden algorithms can make or ruin reputations, decide the destiny of entrepreneurs, or even devastate an entire economy. Shrouded in the secrecy and complexity, decisions at major Silicon Valley and Wall Street firms were long assumed to be neutral and technical. But leaks, whistleblowers, and legal disputes have set the light of automated judgment. Self-serving and reckless behavior is surprisingly common and easy to hide in code protected by legal and real secrecy. Even after billions of dollars fines have been by underfunded regulators, may have only scratched the surface on this troubling behavior. Frank Pasquale exposes how powerful interests abuse secrecy for profit and explain ways to rein them in. Demanding transparency is only the first step. An intelligible society would assure that key decisions of its most important firms are fair, non-discriminatory, and open to criticism. Silicon Valley and Wall Street needs to accept as much accountability as they impose to others, no matter the technology behind. But who really decides? Do you think that synthetic intelligence are unable to design the best solution for human beings? Do we really know what we need? Aristotle said, knowing yourself is the beginning for all wisdom. And Carl Jung said, the privilege of a lifetime is to become who you truly are. So can we use AI to pursue this goal, knowing ourselves? Machines routinely defeat the world's greatest chess players and Jeopardy champions. Smart artificial intelligence algorithms replace tasks performed by lawyers, radiologists, and scientists. As machines learn more how to predictable tasks, your risk or losing of your at this advance, your risk of losing your job increases. But I would like to highlight something about it. First, technological trend in blue-collar work, robotization and increased automation will have a bigger impact on manufacturing in developing countries, while service industries such as retail will feel the brunt in developed countries. The technological threat to white-collar employment, big data and machine learning, cloud computing, and advanced algorithms present a unique threat to knowledge work. Not only automating a specific task, but potentially replacing the predictive judgment of humans. 6 economic reasons why this time is different. Stagnant waves, labor decreasing as percentage of national income, the missing of job creation, rising inequality, graduate underemployment, and job polarization all suggest the economists that this is a different this time around. Why new jobs won't offset? As emerging industries leverage the increased cognitive capability of machines, it's unlikely that new jobs will offset jobs lost. Finally, the consumption paradox and guaranteed minimum incomes. As unemployment increases, consumption would be suppressed, potentially stunning further innovation. A guaranteed minimum income would be one way to address this issue. So the controversy is finally served. The traditional approach to creating value has always been people think up or invent a better way of doing something. That's what we can call minds. Monetize the idea, products, and then build a company around making a product or services, what we may call the core. That basis, minds, products, and core dynamic, is the heart of the modern economy. However, these 3 trends have now arisen. Machines are getting smarter, and when supplied with big data, can learn by identifying patterns and finding smarter ways to do things. Platforms have come along with run by companies which don't have or own anything but just facilitate transactions and resource share. Let's say Amazon, for instance. The internet makes it feasible for crowds working together to come with better ideas than experts. The combined result of those 3 trends is the minds, products, and core dynamic is rapidly being superseded by the machines, platform, and the crowd. The good thing is that with change comes the opportunity. The key to excelling in the years ahead will be to take the difference of machines, using the platforms and the crowd intelligence. I would like to end this presentation, or before ending this presentation, I would like to make a recommendation of this documentary called The Social Dilemma. The film explores the rise of the social media and the damage it has caused to society, focusing on its exploitation of its user for financial gain through surveillance capitalism, data mining, and how it's designed meant to nurture an addiction. It is used in politics, and its effects on mental health, including the mental health of adolescents and rising teen suicide rates, and its role in spreading conspiracy theories like the Pizzagate in the previous US election, and aiding groups as the Flat Earthers. Lastly, by a super intelligence, we mean an intellect that is much smarter than the best human brains in practically every field, including science scientific creativity, general wisdom, and social skills. This definition leaves open how the superintelligence is implemented. It could be a digital computer, an ensemble of networked computers, cultured cortical tissue, for what have you. It also leaves open whether the superintelligence is conscious and has a subjective experience. There will be a strong and increasing pressure to improve AI up to human level. If there's a way of guaranteeing that superior artificial intellects will never harm human beings, then such intellects will be created. If there's no way to have such a guarantee, then we will probably be created nevertheless. I mean, they will be probably created nevertheless. The risk in developing this superintelligence includes the risk of failure to give the super goal of philanthropy. One way in which this could happen is that the creators of the superintelligence decide to build it so that it serves only for the selected group of humans, rather than humanity in general. Another way for it to happen is that a well-meaning team of programmers make a mistake in designing its goal system. More substantially, it could result in a superintelligence realizing a state of affairs that we might now judge undesirable, but in which, in fact, turns out to be a false utopia, in which things essential to human flourishing have been irreversibly lost. We need to be careful about what we wish from the superintelligence, because we might get it. The big dilemma for me is to control the progress of the science and therefore limit it. As we have seen in this presentation, the correct use of the artificial intelligence as a tool is what makes the difference. Thank you very much for your attention. Let me hand it to Professor Jun Seo Kwan. Thank you.
Thank you, Professor Alberto Cordero, and also all other, very prominent, speakers. As all have you gone through, we studied our session with sort of the how we see smart city from various aspects, especially also Professor Yun, as you mentioned, that as a national agenda and data policy, but also we down to also technical aspects of the smart city, especially how to manage the data, and more in detail. And data infrastructure can be actually assumed with a very breakthrough technology with a lower energy consumption. Eventually, the architecture may change. And then over to how, how also the smart city as an ecosystem with the green nature or the smart nature, how we balance, also as a landscape point of view, technical landscape and data landscape and natural landscape, how they can actually co-manage together. And in that aspects also, Alberto revisited also with a sense of sort of the advancement, positive view of the smart city he started in the beginning. From the point of the data economy and other, so we actually, the first part, like up to, Alberto's first sessions, have been more about, what are the potential advances, possible, and we can pursue with the concept, with the vision, with the value of the smart city. Then John, and again Alberto, actually go down toward the very philosophical discussion, starting with sort of the constraints, either technical constraints and social constraints and psychological and also the constraints and probably sort of the human constraints we have and how we can cope with it or how do we need to cope with it. And so we now coming back to the discussion of our roundtable. And as you have gone through, what are the pros and cons, what are the advantages and the constraints. So I'd like to open to the speakers and on this subject, advances and constraints in smart cities under our underlying us the question we have, how to make a smart city and smarter. So definitely on these questions and in this subject, seems like we have a smart city. If we don't have a smart city, then we cannot say what is advancement, what is the constraints. Okay, then what is smart city? Oh, where is it? Which one? And so I think first, there's no, it's a very subject matter, as you know, and but we have to make an assumption and practical assumption. What is smart city? Barcelona? Or Xi'an? Or Seoul? Or and so okay. I'd like to give a flow, from your point of view, what is smart, where is your smart city? And why that smart city actually gives you the point that you can see the potential advances and constraints, okay? If there's no smart city existing, these are all research questions. These are all hypotheses. Advances and constraints, these are the hypotheses. Okay, but because we question that how to make a smart city and smarter. If there's no smart city and then there's no smarter. Okay, so let's go back. What is your smart city? Or where is it? And what advance you can witness on that. So I will probably go to whom, let's say, I'll go over to you. Who will be the brave man, to talk about your smart city? One or two.
Actually,
Okay.
I think I can go first.
Where is your smart city? Okay, John.
So I would like to rephrase your question. Are we asking how is a smart city smart? If we replace the smart city there in the first smart city with just city, what's the difference? How can it make our city smarter? The question.
No. Oh, what is your smart? Where is your smart city?
Sorry.
Where is your smart city? Don't tweak my question.
Okay.
And we have assumption that we have a smart city. I say it's a subject matter. What is smart city? Where is your super? Have you lived in smart city? Without living in the smart city, how can you say what advance you have witnessed? I have my smart city, but I'm not going to tell now. Okay, so go ahead. Smart city, Jose.
Yeah.
Fiona. Okay, please.
In fact, I think we all live in smart cities. At least I feel myself smart enough, and probably many other people are smart enough. So probably my city is smart enough, but probably it needs something else to take advantage from that smartness. And that's the key point, is there has been lots of work devoted to put technology, in fact, is to artificially put artificial intelligence in the city, instead of looking ways of making our lives easier, making our lives more efficient, making easier collaboration, because the smartness is already there, but probably we need some support from technology, and there is the technology is already there. I really think that the digital transformation is going also to transform our cities, and because data analysis is more democratic than many other things. Almost anybody can take advantage from data, and not everybody can take advantage from, I don't know, making buildings, you know. That makes data a framework for collaboration and from taking advantage from different groups that is much more interesting than any other technology in the past, and the potential, I think it's huge. That's my personal.
Thank you, Jose. And yes, so I think probably advancement, you mentioned, really, kind of capability of how to manage data within the city you're living in, and probably I think you will witness some of the, probably improvement in how to deal with the data. But much more to go, but some of them are smart enough to let the people to communicate better, or let the people to cooperate better, let the people have a higher trust level, and let the people have a more safer, even sharing and opening the window, open the door, right? So there's no probably wall to be blocked, on the houses and also on the offices and other things. Okay, thank you. And someone else? And from Korean side, who are they? Probably Professor Song Young-gun. I know you've been visiting many cities. So where is your city?
Actually, in Korea, we have 245 local government, and which means we just call the smart city, but the situation is very different, so very, very diverse. And about your question, my answer is what is the smart city is closely related to the question of with what is the problem of the city. So because all of the, and we, based on that kind of problems, and through the bottom-up approach, we should think about the solution using smart city. Some city for example, some city, the most big problem is about the waste, and some cities about some lack of green spaces, and some cities are suffering from some noises and smells, and and some the problem is very different. So, for example, our city, which is located in the mountain, we should think about the smart mobility, but the infrastructure is very different from it's like a big mega city, right? So in that case, we should think about different smart technology, even in the same topic of the green, so smart mobility. So my answer is the smart city should be at the smart city should be different depending on the problems of the
city problem. So where is that city? Where is that smart city? You probably say, okay, at this moment, so that city made that problem of solving and then made this solution, or that city still made the probably say identify the problem, but there is some country. So what that smart city? Where is it? In Korea or anywhere else?
I don't know, but
I'm asking for pronouns of the city.
okay. The scale is, I think, depending on people, everybody imagine different scale of the city. Someone imagine the smart city at the smart city scale, but I think the smart technology is not yet to be applied at the scale, city scale. Sometimes. So maybe small scale, for example, local and district scale. Well, yeah, some technology is tested at that kind of scale.
Okay,
but,
Professor Song, thank you. Probably a very diplomatic, and also, since it's a YouTube broadcasting, and so
Okay.
I'll ask anyone else who maybe John.
Yes, physically, actually, according to the reports by Bloomberg, I think it's that the smartest cities in the world, like they listed London and Tokyo, Singapore, and so forth. But actually, I wasn't so convinced with the list. I can't see the smart city already existing in anywhere in the world.
Okay, thank you, John. And so I think who are the one that making that call that city is smart or not? Not by the consulting firm, not by the Bloomberg, it's by their citizen. So, but probably I don't know. Probably that is from the citizen or not. But so let's see. Let's have a discussion, and so, and maybe I will ask Professor Yoon, from your point of view, where's your city?
All right. In my perspective, smart city should enhance the citizens' quality of life. And in that sense, my smart city in Korea is my hometown. Because, my hometown is very small city, Jeonju City. And when I be there, my quality of life is, dramatically increased because my parents are there, all the atmospheres are very, experienced to me, and I feel very comfortable, and I know the interactions with my surroundings. So my quality of life in there is, compared to the life in Seoul, is really different. So I can say, in terms of the increasing the quality of my life, quality of the situation, I can say so. But I'm sure the smart city here means, as we all discussed during the sessions, is to create some new value with the new emerging technologies, and to solve some social problems with this, some technologies and some new philosophy from this city. So maybe I can just expect my new hometown in terms of smart city, maybe in somewhere else. I'm waiting for it.
Okay, thank you, Professor Yoon. And so also I have chance to visit, Jeonju, and I found that very history well kept and also traditional, food, cuisine, and architecture, but at the same time adopting some new innovation. So also the people like you, who still admire going back and see, and probably I try to keep the people's relationship. So thank you for sharing. And Alberto, probably, and would you like to add? You actually balanced, your talk both in the very advanced side and also in some of the country, from the technological point of the smart city.
Yeah, that's why I want to relay in the human side, because I think it's very important for us. I mean, especially the people who has like us, that we are every day very focused on the technology, to think and to stop to think if we are really doing the correct thing, because at sometimes we're slaves of this science progress. When I talk about the sustainability, I mean, for me, it's obvious that the progress of the science is damaging the country, the countryside, I mean, and the world in general. I mean, probably because of the human behavior. But if you see this docudrama that I sent right away with from Netflix, they say that there's no evil man behind. I mean, there's evil, but it's not localized in one human. But for answering your question, what is a smart city? I mean, mainly I feel myself that a smart city is more a buzzword than really, I mean, the need that we have for organizing things. I mean, in Spain, some cities comes from the Romans. I mean, they are organized by the Romans 2,000 years ago. So, and we're using the same structure. Just think about the Saudi Arabian NEOM initiative. I mean, they want to build from scratch a smart city. It's really smart. I mean, Johnson put a very good example of the failing of treating to be smart upfront. So for me, we would like to. I mean, I would like to think like Professor Yun, that our aim is to be happy more than to be yes. Than there's a service from the city that have to give to the citizens. Okay, and that's it. I mean,
yeah, maybe thank you, Alberto. So still we see that citizens actually make a decision, what is smart or smart not. So well, I've been questioning. Actually, I'm an information scientist, not only the engineer but information scientist. I've been questioning and human intelligence, human capabilities are advanced by our languages, our information, but also we are constrained by our languages. How many vocabulary, what language I'm using, actually make our thinking to be defined by that language's meaning and her. So back to smart city questions. Who created this smart city? And so I've been actually going back, and so it's a link these days, with a smartphone and smart TV, and it's a very buzzword, like you say. It's actually commercial word. But before smart city, who made this cities, ubiquitous city and digital city, and so, who made it? I found it. It's a commercial. It's a business. So yeah, in the beginning of era of computing, in the beginning of networking, in the beginning of when we have digital convergence coming up, and everyone is chasing for the hegemony and also kind of the leadership of this new economy, or what we so-called information age. And digital convergence, Big Bang, has been happening. And so, the computing manufacturer, like a Hewlett-Packard lab, created a version of, how the city life will be different. Probably some of you may seen that, video, or, when Hewlett-Packard claimed sort of a future of the city. But at the same time, then, so these ideas actually, more not only driven by only that computing, and then by the, let's say, network or wireless. Then the city was visioned by telecom provider like NTT, and you may see some of the video. Now, so those words are driven by many of those, kind of competing in this digital competing technology form. Recently, these are driven by Urban City by Toyota, right? And so the city will be for logistics and also automobile and mobility, right? And that defines different level of life. And so in the mountain of the Huzi, and then people try to come up with that the imaginary city, then Toyota Dream, and then like the people there. Okay, it's not bad to be driven by the commercial because they are the leader. They have a big value to make money, but we want to go back and see, did I ask for smart city? Or did we ask? Or are we, and so, or such our outreach still touch our heart or not? Okay, I found that I talked to many people in many of the city and my city, and asking people, what is smart city? Do you know our city is smart? Do you know our city is smart city? And I found that most people do not know. They cannot say whether it's smart or not in general. No. They can say, oh, this is a good city, or I like it, or not. No, but they cannot say, what is so such kind of very dedicated, subjective, definition of the smartness has been driven by these things. So, well, it's a subjective, but actually it's a good momentum for us to see, what kind of imagination we are having, idea we are having. I'd like to say that the people have been moving over to the city from their hometown. Hyunyoung is living in has been living in a small, city, but she has been moving to the larger town and larger city. And that's the city. That is the identity of the city. The city has been probably occupied or has been used as a platform. People streams to be filled, or people's vision, and also maybe audition opportunity or the changes. Maybe some people has been city grown, but they have been actually see what the city is. And also there are different evolution of the city. For example, some city has been traditionally from the beginning a city, or from the beginning of a place people to live. So naturally, the governance and culture, right? Like Athens or Rome or somewhere. But some of the modern cities are, full, probably by the administration, by the government, by the election criteria, artificially defined. I never want to be the city of the new name of the city until new governor changed the boundary of that city. So those are the really, these kind of thing. And so I'm going back to the question from my answer to this one. Well, I have a smart city, and this is where I am in, Siheung. So I can witness many of the things. This is very industrial area. And so it has been, probably recognized by many people in our living age, and then very polluted, very, and heavy dust and smells and dirty water on the sea. That is the imagination of most of people who haven't been here. Not at all. It's a very clean city. Like Pittsburgh changed from the steel city to the dolly city, this city has been changed in that way. Definitely, it's much smarter than 10 years ago. Definitely, it has a vision to be smarter, before. So, second one, why it's a smart? It's a planned city. It has not only planned, it has a plan to fall. And that planning is not by one governor, it's by the collective wisdom. And bringing the people who will join that vision and who will join the plan. And so, probably I'd like to actually visit Exponential Education, friends, to come to my new campus, Smart Campus, and also Smart City, we call Siheung. This Siheung is also nationally named smart city. It's not perfectly smart, but it was smarter. So I have my actually answer to that. But as you can see, technology play very important role in our modern society. We cannot ignore the role of the technology in this, in the especially society, in the city. The role and impact of the technology are much higher than before, right? And so, and also especially data, Jose mentioned, right? And also especially intelligence or blockchain. So especially the technical system and also how to manage that system, how to adapt those systems with the social architecture, or though we probably need the really people to interpret two different words to be together. And that's why I believe education or university will play very important role as a kind of the agora or polis, where all the knowledge or the people to come and discuss and build and rebuild and change. So I believe, we are all imagining the common thing together. And I don't believe actually we can come up with all the answers today, but our discussion, may inspire, many of the audience in the YouTube. Probably, I think, we will still find more smart cities. I hope actually we continue our venture. But I have we still have 5 minutes left, until we finish. John was asking for, some of the comments. And so feel free to add additional comment on, before we close the discussion today. So John, over to you.
Thank you, Professor Hang. Actually, I think that philosophical, conceptual, or semantic discussion about the meaning of smart city is very important, but we cannot stop there. We have to move on. So I think what's more important is how we do developing the smart cities and what are those clear results we are aiming for. If we are clear about procedure, our actions, and our design toward smarter cities with a clear purpose of making people happy, healthy, safe, and enjoying life, as Professor Yoon said. So it's more important for us than defining what exactly smart is. So that's my last comment. But one thing to add is that data and intelligence is a really, really absolutely key. It's at the essential core of all our efforts toward smarter cities. So I think it's very important to have a really clear architecture and how we can use those information to inform citizens to come up with the actions they can take. Thank you.
Thank you, John. And someone else? Yeah, 3 minutes left. And so, yeah, thank you very much. Well, data, so rephrasing your, comments. Data, in the city, we have many utility and also, constructions. The important thing in the city is a street and road plan. And so plan road and plan city, and also that is some dedicated and designed area that makes city different from, right? So in most of the city has a residential, so you have a pre-planning. It's not naturally, where you decide how to live, and so the road are right now replaced by data. Mm-hmm. Data center, data class, the cloud, will replace the road, our SOC, right? And so definitely the landscape of physical construction will change depending on how we make our data available, in what way. Using such data and making, driverless or unmanned vehicle, unmanned, flight or drone will probably erase and the need of the road anymore, and also light. We don't need a light on some of the street because you don't need to you need to move around. Some other things will do that for. Okay, so that is very important. We have to think, about in that way, not to create another construction, another road, another apartment, another high-rise. I don't think that's the way. Our data will replace many of that. And okay, Professor Yun, do you have something else? Oh, okay. Professor Moya, you have a comment?
One more comment about that is that, well, in fact, you were talking about the role of the road in the past, the role of the data, and the interesting point of this digital transformation of the city is that we are moving towards something that first we cannot optimize what we don't know, so we had to first have the knowledge of what is going on in the city, and that's something that is not a reality currently, not even in New York or London. So knowing what is going on in the city allows you to be very efficient in the use of resources, and but one thing that enables that transformation is cooperation, and it's not possible in a smart city if we don't change our minds. And for example, if you say, no, the smart city that Toyota proposes or HP proposes or whatever, those are probably complementary views of something that could be something similar to a smart city. But if they don't agree on sharing their views and sharing their data, so that we have a common platform from where to get benefits, and also to give back data so others can get benefit. If we don't reach to that point, we cannot have a real smart city, and that changes. It will take some years.
Yeah. Thank you, Professor Moya. Yes, data economy, data federation, and also the society and community with the open or shared data, and so it has create another vision for the smart city. Maybe those are some of the additional topics in our next session of our SNU Exponential Smart City workshop. I look forward to having additional workshop before the end of the year, between your university and our university, and we have further discussion with so. But I'm very happy, and that all our SNU colleagues and also our Exponential Education faculty have met together, who I'm know both, and then I hope we can build also another open community, and with a vision to make really the smart city smarter.
Mm-hmm.
Okay, thank you everyone, and look forward to seeing you again. Hope all of you have a great day and also night. Thank you.
Thank you.
Thank you.
Thank you very much.
Thank you. Bye bye. See you later.
Thank you.
See you later.
Bye bye.
Bye.